This comes out of section 7.1, Limits of Trig Functions. In this section, our main limit is really the limit as x approaches 0 of sine x over x. Now, you can't just put in 0 there because you're going to have the 0 over 0 problem that we've run into a whole bunch of times. So we can, put in some numbers and check to see. There is a way of proving this. Kind of uses the unit circle. Your textbook on page 303 does a nice little proof of the fact that this limit actually equals 1. If we try putting in some numbers for x, 0.01 or 0.01, and see what happens with sine x over x, you will get numbers really close to 1, like 0.998, depending on where you decide to round these off, 0.9999, as many decimal places as you want. If you make this number closer and closer to 0, and same with true, even if you go from the other side, if you do negative 0.1, you get 0.9983 something, and negative 0.01, same kind of answer, 0.999983. So that doesn't necessarily prove anything, but it sure does look like it's approaching 1. The fact is that it is, and again, I'm not making you responsible for proving that, but if you want to take a look at your book, you can see it. Would like to remind you of one thing, what a sine graph looks like. Hopefully in your preview to chapter 7 you reminded yourself that this thing has an amplitude of 1, a period of 2 pi. You know some of your important values from the unit circle, etc., because those will prove useful later on. And the difference between that and the cosine graph, that has a lot of similar characteristics, but it's as if you shifted it over a little bit, so it still has an amplitude of 1 and a period of 2 pi, but passes through the point slightly differently. And again, the unit circle can help you remind you some of those values. So, given that this limit is true, and really I don't ask you to memorize much, but that's something that you want to remember, that the limit as x goes to 0, sine x over x is 1. We'll be asked questions like, find the limit as x approaches 0 of sine x over 2x. Well, something like that, you can really just take out that 2 by saying, well, I've got 1/2, now the limit as x goes to 0 of sine x over x. So the answer to this limit is 1/2. The limit from above is 1, and we have 1/2 times that. So that's kind of your simplest version of this. Now, if they put a number inside, like if they say, what's the limit as x approaches 0 of sine 3x over x, I can't just divide out that 3 in the same way because it's sine of 3x. It's part of the sine function. But what I can do is artificially place a 3 on the bottom to say, well, I know that would give me 1 because sine 3x over 3x is going to approach 1 just as sine x over x did. But if I've put a 3 in the bottom, I would have to put a 3 in the top as well to make sure I'm not changing the value of anything. So what I have is 1 times 3 is 3. So this lesson kind of becomes an exercise in manipulating these things. If I have something like the limit as x approaches 0 of sine 11x over sine of 5x, a lot of students get kind of stumped here. But if you play with that one as well, you could say, well, I could make it sine of 11x over 11x. I know that would give me 1. I could make it sine 5x over 5x. I know that would give me 1. But on the top, I had to multiply by 11x on the top and the bottom. So in here, I had to multiply by 5x top and bottom. So in the end, what happens? This becomes 1, this becomes 1, x over x becomes 1, and what I'm left with is a limit that approaches 11 over 5. So kind of a tricky way of manipulating that one. The next one that I'd like to last one include in this example is the limit as x approaches 0 of cos x minus 1 over x. This one proves to be almost as important as the one we have up above, and to the point where some people even memorize it, but we don't need to memorize it. One way to get this going is again, if you put in x as 0, you're going to get 0 over 0, no good. But if I use the tool we used back in Math 30, something called the conjugate, I do it top and bottom, which means I'm not changing the value of anything, but I will change what it looks like. I'm going to have cos squared x minus 1 over x times cos x plus 1. The denominator doesn't look any better, but the numerator, if you recall, if I factor out a negative, it might look even more familiar to you to say negative 1 minus cos squared x over x times cos x plus 1. That gives me sine squared over x times cos x plus 1. Now that doesn't seem a lot better, but the only problem with this limit in the first place, the only reason why I can't just put 0 in is because of that x in the denominator. And what we have here now is we can say, well, we know that the limit as x approaches 0 of sine x over x, that gives me 1. So what else do I have here? I still have a negative sine x on top, and I have a cos x plus 1 on the bottom. Well, now that this piece is gone, essentially, I can put in x as 0 and I get 0 over 2, which is not undefined or any problem at all. The answer to this limit is 0. A lot of work to arrive at a 0, but pretty useful limit nonetheless, and something that you will see. That use of multiplying by the conjugate is something we've seen a number of times.